There's just like a delay. Yes. Okay, well, hi everyone. Thanks so much for joining us. So I'm going to tell you about the DevSlop project. So DevSlop stands for Sloppy DevOps, and it was Nicole's awesome idea to give us the best name ever. And basically, we as security professionals wanted to understand how we fit into DevOps. Like, how do you do security testing in that environment? How do you do compliance auditing? How do you do application security? And so Nicole's like, let's start a project. And I said, you had me at hello. Yeah, and so we do a whole bunch of things. So we have a whole bunch of different pipelines that we've created and proofs of concepts to show things off. A lot of us do workshops and teaching in all these different ways. And we have this show where we have really awesome guests on, like Rosemary, who teach us something new on a regular basis. And so if you like this show, you might like all of our past streams. So you should check us out. Cool. Thanks, Nancy.
So Nicole.
Yeah, my name is Nicole Becker. I'm on Twitter as the Dead Robots, but I'm a little shy on Twitter, so I don't post nearly as much as Tanya, but I am there. I've been in this application security space for a long time, probably about a decade. And, I'm an adjunct at NYU, and I currently work for, a big corporation doing a lot of, security and application security type stuff. And I love this space. I think it's a really great space for everyone to be in, and there's plenty to learn, and I'm really happy to be here. And today, our guest is Rosemary from Hashicorp. And she's going to tell us about who she is and what she's here to tell us today. Rosemary.
Thank you all. It's so exciting to be on here. I'm Rosemary from Hashicorp. I am a developer advocate, primarily focusing on Terraform, but I've had experience across a lot of the open source tools. Hashicorp has a lot of them. There are 6 of them. If you can name them in the chat, I'll see what I can do to send you a sticker. But the interesting part about my career was that I started as a DevOps engineer, and to this day, I'm really not sure what it was or what the role was about. DevOps at the time was really difficult to define as someone who was doing the responsibilities, right? So I worked in compute, storage, and network for quite some time, and then worked on public cloud, eventually sort of developed an interest in migrating legacy workloads on data centers to public cloud, and eventually moved to being a developer advocate, where I get to learn a lot about what other people do, synthesize that material, and understand some patterns and really interesting approaches to how you can use some of these tools to better provide solutions for some workflows that you may have. So it's been pretty interesting. My security background has been mostly working with some amazing security professionals who've taught me a lot. So it's been really fun to have this great exchange between code and DevOps and security knowledge.
Great. Thanks,
Awesome.
Rosemary. Should we kick this off, Nancy?
Yes, sure. So what's the plan? I know that you've had a bunch of demos for us, and you provided your live share. I shared the link in the chat, so if you want to join us eventually, just...
Yeah. Definitely join the live share. If you're interested, I usually do a lot of code demos, live demos, for better or for worse. We'll see if today's work. If not, then we'll just go through some of the code, and it might be easier to see the code. I realized that when I was doing some code walkthroughs, it was really difficult for people to see because font or color contrast. So you can go to hashi.co/OWASP-TF for Terraform. And that's a short link to a VS Code live share. So if you're interested in looking at what we're looking at, I'll also share it on the screen as well. But it's a very interesting way to just understand and learn how to code. You'll also see the repository that I'm using as well. But basically, I sort of was talking to Nancy, like, what do we talk about? And one thing that came up was infrastructure as code. A lot of people have heard about it. There's a book on it. There's amazing information. There are a lot of open source tools, but there's not much about scaling the pattern. So like day 5 operations of doing it. So this ranges from doing infrastructure as code to collaborating on it in a way that scales. And then the last piece, or the last couple of pieces, which is how do you secure it? How do you make sure you're doing it correctly? But on top of that, how do you make sure that you're putting the right testing in place so that you're getting the value out of doing infrastructure as code. So the more general concept about infrastructure as code is applying software development practices back to infrastructure. And application development practices are really amazing, and there's a broad spectrum of them, and not all of them map directly to infrastructure, as I found out really early on, especially in the data center space. If you're plugging in a switch, I don't know how you exactly test it, other than maybe like a smoke test. So you plug it in, and if it smokes, you know it's something gone horribly wrong with it. And so infrastructure as code became more popular in public cloud because you were able to get resources on demand really quickly. And there are amazing APIs that you can use to interface with all of the public cloud infrastructure out there. Many of the cloud providers, whether it be Terraform, GCP, or Azure, know how to do it really well, and they build some really well-behaved APIs. So it makes it pretty easy to actually interface with them in an as code or as configuration manner. And there are a lot of tools that help you do it. If there are any questions, feel free to post in the chat. I cannot see them, but anybody else on the team, please interrupt me if there are questions that come up as well.
Don't worry, I'm watching for you. I got you.
Thank you very much. So one thing that I really enjoy starting with infrastructure as code is understanding the intent behind it. And I think this really maps well to what we're going to talk a little bit about in more depth, which is the security and policy aspect. What's really tough about infrastructure as code is that it's really, really, really specific domain knowledge. So if you apply clean code practices from the development space into infrastructure as code, it's a lot harder to describe a load balancer to someone who's not in technology. You can describe a payment system and maybe the user journey of how a payment system works to someone who's not in technology, but you might have some difficulty explaining what a load balancer does in infrastructure language. So it's really hard. And so there are a lot of tools out there that kind of help facilitate this, one of which I work on and I work with quite on a regular basis. And hi, everybody who's joining. So exciting. One of the ones that I work with the most is Terraform. As you can see in this live share here and also in the stream, hopefully, what you'll see is that a lot of this doesn't look like a programming language. So for those who are more familiar with Java, .NET, .NET C#, any of the other programming languages, it's not really a programming language, it's a domain-specific language. And the reason why it was built this way was that a lot of people don't really understand, at least in operations formerly, although it's changing more, but formerly in operations, a lot of people didn't understand constructs of programming, right? And it's really difficult to tell someone, well, I'm firefighting my infrastructure, trying to make fixes, but I'm also having to learn code on top of that. So this was a nice middle ground to get started, especially when, for me, right, I learned how to script. I didn't really learn real amazing coding practices and clean code practices until maybe 3 or 4 years ago. So this was a good way for me to get started and to grow organically into understanding more about scaling my development practices. So if you're more or less familiar with infrastructure as code, this is probably something you'll see. There are a lot of other tools out there. Today, we're going to focus on purely open source tooling. If you're interested in CloudFormation or you're interested in Azure, resource management and the Google Deployment Manager, et cetera, there are a couple of them out there. Those are, very specific to clouds, certain cloud providers. This, Terraform is one of the ones that's got a lot of providers out there. So there's a huge list of them. I won't go through all of them, but some of them interface with like Cisco switches and a lot of other infrastructure as well. So what you can see here is that I should be able to read this a little bit like English language. So I can say, hey, resource, Azure Postgres server, I'm creating here. I've got a location for it, and I've got the instance sizing, storage profile, password, version, whether or not it's SSL enforced. So the whole idea behind this DSL, which is called Hashicorp configuration language, is basically to allow you to read it as close as English to possible so you understand intent. And for the most part, infrastructure as code, in terms of having a DSL that you can come back and say, here's the information, this is codifying your configuration. So as you can see, I've got a lot of configurations and they're all checked into Git. They're all version controlled. If I make changes, the idea is that I can see them and what changes I'm actually making. So a lot of this, if I make changes, for example, to even the location, maybe the location goes from, central US to East US, or even somewhere around the world, I'll be able to see what exactly it's doing. So any questions before I go forward?
Yeah, sorry, Tanya, were you gonna go, Tanya?
I'm wondering, so I'm in VS Code in the live share, but I can't really figure out how to see what you're seeing.
Oh, okay. So there is a little, I think you have like participants, right, on this?
Yeah.
So I'm going to use Nancy. So you can click on that and you can hop to the file that I'm actually hanging out in.
Okay.
Yeah.
Okay.
So you can click on participants and then you can hop into it.
Okay, cool.
And there is a focus tool, but I never actually used it. So, well, if you find me in here, and I think you can also pin so you can follow them.
Okay, cool.
So right click and you could click follow and you'll be able to follow as I jump around some of the files. And you'll see where my cursor is. So you should see my cursor highlighting this block here.
Okay, cool. Thank you.
So I was wondering, just from a high level perspective, the awareness of like configuration and security control within this Terraform script, like what sort of things can you contextualize here? Like, I guess, for example, like obviously the usernames and passwords are stored as environmental variables. If they were hard coded, that would probably be a configuration risk, security risk, and that would probably be flagged, right? If you tried to deploy in a region that maybe your company isn't necessarily comfortable deploying into because of some data privacy issues or things like that, maybe that would be a flag. If you're spinning up something that's like, oversized for the use case, would that, like, I'm just trying to get just some high level awareness of what you can contextualize in here, just so, yeah.
Cool. That's a great question. And that's kind of the problem, right? The way that Terraform specifically works and a number of other tools, they're actually going to be declarative in nature. So when you say something is going to happen, it will happen. But the problem is you don't know if it is actually correct or compliant or secure. And that's where the problem comes in. In terms of the context in here, it's all captured, but you have the tool itself has no concept of whether or not it's right or it's wrong. And that's where the risks come in. When you start to collaborate on grand scale, you might have a lot of engineers who don't necessarily know these unknown knowns, right? So these are, if you think about a grid, right, of known knowns, known unknowns, unknown unknowns, and yeah, exactly.
Unknown knowns and unknown unknowns, I think.
Unknown unknowns, yeah, exactly. Yeah. These are the unknown knowns that usually are encapsulated in different groups and different subject matter experts, right? So part of that is just not captured in here. So for example, this password, I would have no idea if this password is compliant or not, if it's hard coded or not hard coded. I'm asking them to pass it as variables, but this is something that I would need to check, or I would need someone to say very specifically, you ought to be passing this as a variable and not as something hard coded. And that's, but yeah. So I do think that becomes a big issue because not everybody knows this information. For me, when I was first starting out, I didn't know enough networking to say that a 000 TCP rule was really bad. And in some contexts, it might be fine, but in other contexts, it might be not so great at all, right? So part of that was saying, how do I learn that? How do you communicate that across teams when you've got maybe 100 teams depending on this infrastructure, or maybe spinning up their own pieces of infrastructure as well? So it's really difficult to do. And that's why there's security as code, and there's this big concept of policy as code now. And even more generally, there's a book by Rebecca Parsons and Neil Ford called Evolutionary Architecture that actually describes this more general unknown known bucket as fitness functions, right? They're architecture abilities that you want, capabilities that you want out of your system, and you need a way to measure how close you are. So in some ways, the way that policy as code and security as code is implemented, their fitness functions to determine how conformant your code is to a specific security architecture or a policy architecture. And that's where you see tools like Terraform's Sentinel, which is not open source, as well as Open Policy Agent, which is what we're going to actually talk about today. Any questions before we go to open source?
Everyone's really happy now that we're on the live stream with you.
Oh, I'm so glad. And then, okay. So what we're actually going to do is see this in action, right? What I've done is I've actually staged this beforehand. I'm creating a Postgres SQL server, and I'm also creating a Kubernetes cluster. Kubernetes, fairly common technology that's mentioned a lot now, and you can create clusters. It's a workload orchestrator, so you would be scheduling application workloads on top of it. And so you do want to have some kind of security in, as Nikki mentioned before, policies on this, right? You don't want to spend a lot of money on a cluster that expands infinitely. It's probably not very compliant with your cloud build. So maybe you want to put some limits on that. So here we're using some Terraform. We're saying here's a container cluster on Google, on GKE. And I have a couple of very short parameters, initial node count of 1 in terms of my actual node pool, which has all of the, sort of workload scheduling resources. I have maybe a maximum of 3 of them. So I'm limiting how many I can have. And you have some other configuration here. I'm not going to go too deeply into them because we're actually going to go and examine them a little bit further, but this is just a quick declaration of what it looks like. And I also have an Azure managed database, Postgres database. And this is going to allow the application to connect to that Postgres database. So application on Kubernetes connects to Postgres database that's managed in Azure. So we've got 2 different clouds, 2 different types of policies, 2 different technologies, different concepts, different ideas, different implications for using both. So part of the problem is I can deploy them, but how do I know, as someone who might not use this on a regular basis, how do I know what's good? How do I know what's bad from a security standpoint, from a compliance standpoint? And as it turns out, I did actually try to apply it. In Terraform, for those who haven't used it before, there's a dry run capability. So what it will do is it will tell you whether or not it's creating something, if it's destroying something, or if it's replacing something. So here I'm in a pipeline. It's because we're running infrastructure as code. So we want to make sure we treat it like software development applications, right? Where you're going to maybe put it in the pipeline. And if you've seen a previous DevSlop, I think someone went through actually adding container security scanning, et cetera, or general security scanning. So if you add security scanning into your pipelines, this might be the same thing you do for Terraform as you would do for application code. So here I just have all the resources that I'm creating. As you can see, there's a lot of resources. And when I actually approve it, which I did, as you can see my face here, I've approved it. Then as you can see during the apply, we had some kind of issue. It did fail. So most things got created. The firewall for Postgres, for example, got created. Database got created. But we have this lovely error that says master auth password must be at least 16. And we didn't catch this during dry run.
Where are you seeing that? I'm sorry, I can't see that on your screen.
I think you're in another monitor.
I am in another monitor. Let me do that. Okay, how's that?
Oh, perfect, beautiful.
Yay, all right, I shared the wrong screen. Sorry, everybody, technical difficulties. Okay, so here you can see that this is something that I didn't know about. This is an example of an unknown known. I'm not going to go into the Google documentation and scour it for the exact password length, for example. And I won't find out about this until Terraform makes the API call to Google, and Google says, hey, your password needs to be at least length 16. And I wouldn't know that. So part of this is saying, well, let me actually look at how long it took to do this. It took about 5 minutes here in this stage to actually create the database and find that this was a problem. And maybe I would have gotten up and gotten a coffee, but wouldn't it have been nice if I had known this earlier? for example, if I had known this maybe a minute, 2 minutes in. So part of this idea of infrastructure as code is saying, how do we eliminate some of the lengthy feedback cycle we get from infrastructure?
So Rosemary, just to ask you to help me understand this a little bit better, the Terraform script is something, I mean, yeah, you have that written in, you're writing that.
Yep.
That is all being executed through Circle CI, which is your pipeline tool.
Yep.
And OPA is integrated into Circle CI that's doing the checking of the Terraform script you're pushing into Google's cloud and Microsoft's cloud.
Precisely. Yes.
Okay, cool. Just making sure I got that. All right, got it.
Yep. Yeah. So usually in typical first iteration infrastructure as code, there is actually no OPA involved. There's usually just like push the change to production.
Yeah.
So pretend the policy stage is not there. So usually you would just create it and then you hope it works, right? And that's kind of what happened here. I hoped it worked.
And when you install OPA into a pipeline, is that a hard installation or is that just like, how does that work? What does that look like?
So in the pipeline, if I were to add the tool itself, I add it as another dependency as part of the CI runner. So for example, in the case of Circle CI, I use containers. And so I actually have a container that I've created myself that is called Circle CI GCP agent. And it has all the dependencies installed. So it has Google Cloud, Azure, it has Terraform, it has OPA in there, it has another variant of another wrapper to OPA called conftest. So all of the dependencies I put into that runner, and that runner is also security scanned. It's also tested as well. So that's for another day. Yeah. But this is a hard installation. OPA, which is called, it's actually Opa. Opa is what I'm told how it's pronounced.
It's like Greek.
Yeah, Opa. It's Open Policy Agent. We brought it up a little bit, but the idea is that it's a policy engine. It's a way for you to evaluate certain documents or certain metadata in order to understand whether or not it's compliant or not compliant. So it uses some declarative language around whether or not this metadata that you're creating is compliant with what you're looking for or not. It could be any document. So in this case, we're just using the Terraform, and I'll show actually what Terraform it's using.
Got it. Thank you for that.
No, thank you for asking the questions. I appreciate it.
Just want to make sure I was getting it, but cool.
Yeah. In retrospect, I should have just taken out this policy point and just done this straight apply, because usually, again, that's usually kind of what it looks like. Most of the time you just sort of apply it and it's, you just sort of say, oh, I made the mistake, and you'll only find out maybe 5 minutes in. And it's great. You could have gotten the coffee, but I also could have corrected this very easily, right? So password must be at least length 16. So let's actually think about a way that I would get faster feedback, right? And that's where this policy stage comes in. What if I could write a policy that actually said the Google password has to be at least 16 characters? And that way I actually get that feedback very early on. So as someone who's developing this Terraform or any infrastructure as code, I can figure this out really, really early. And then I don't have to wait for it. But also, I actually conform to best practices set by my security teams, by other subject matter experts, even in compliance too. So we're actually going to go back to this, and we're actually going to show what this looks like. So if I were to develop a policy to say, Google's password must be at least 16 characters in length, I can actually build something around that. So this is where OPA could come and help. If you're doing pure open source and maybe you're just getting started in this space, you want to learn the language, you want to learn what it means to add policy testing into pipelines, what it means to test Terraform, for example. This is a good way to just get started and get started locally. So you don't have to spend the extra money on learning all of the other tools. But here, what we have is basically a policy statement. Policy statements should be readable. They should be able to tell you what they're checking for. And so that's what sort of drove OPA's language. OPA's declarative language and syntax is called Rego, R-E-G-O. If you're interested in more information, I'll pop up the actual docs for a second. And you can go to openpolicyagent.org. So it's a policy engine. And as you can see here, all it's doing is evaluating a JSON query and then checks and sees if it's good or it's good based on the decision that you tell it to make. So Rego in itself was intended to not be purely code. It was meant to be declarative. It was meant to be intent oriented. And so one way that you might actually write it is to, sort of write it more in code, which this is actually a coworker of mine pointed that this is not very readable to a certain degree. I mean, it will tell you it checks the max node count, but it's not fully accurate. So if you read it out loud and it doesn't really make sense, then it's not really a policy that others can understand. So as you can see, there's a lot of other logic in here. We'll go through one of them in more detail as we write this password policy, for example, that this is just the basics of what it's running. So if you're actually looking in OPA, for example, OPA basically evaluates these rules. So I'm actually going to open up this. So the first command you'll ever probably use in OPA is Opa Eval, which means evaluate the rules. So right now, as you can see, all of the rules are saying these are the deny rules. And these are sort of the nice message information that tells me that I'm not compliant in certain ways of my policy. So this is the result. So if we think about this as the result of OPA itself, of making these evaluations, let's unravel that backwards, right? And I know it's a little confusing, but it's a lot of syntax. So we'll start actually by writing a policy that checks for the password, right? So we want to make sure that the password is a length 16. And the first thing we want to do is we want to say, okay, again, ignore these top ones. These are a little bit less readable, but we want to ensure that, let's say the policy is 16, greater than 16 characters. So we want to actually start with a function. So what is a very descriptive function? Anybody have any suggestions? Like Google Container Cluster? Oh, I think someone's on mute.
Check password length.
Google Container Cluster password length. Awesome. All right, so what this is doing in here is creating a rule. And this rule basically says it's a return value. So if there's brackets like this, square brackets, it means it's returning something. So we're going to just do that for now. We're not going to mess with it too much, but we're going to do that for now. Now, the tricky part about Rego that I found was that it's actually, you have to retrieve a document from somewhere to inject sort of the keys and values, right? So it's looking at a JSON blob and evaluating keys and values. And so how do you get the JSON blob into the function, into your rule, to check? So the way that you do it is that you actually specify something called an input. So as you can see here, input is actually the blob that's coming in. So input is always the JSON blob you're passing in. And then you always have these JSON hierarchies because JSON is made of keys and values. So here I have a JSON that's plan values, root module, child modules, resources. So what exactly is this, right? This is actually the JSON blob that comes out of a Terraform plan. So when Terraform makes decisions on what to do, as infrastructure as code, it has to know, right, the differences between everything. It has to know what exactly it's going to do. It has to inform you what is the difference between your previous infrastructure configuration and your next one. And the way it actually assesses this is actually with a JSON schema of sorts. So as you can see here, this is the JSON schema that comes out of a Terraform plan. So in Terraform, you have a bunch of variables. As you can see here, you can see my password in plain text. More on that later. But the idea is in here, right? I have some plan values. I have root module. I have child modules. So remember that schema that we showed before. So I'm going to open this to split left. And then, oopsie daisies, I did that wrong. Let me just open it to the side so you can actually see the schema. But remember how we actually retrieved here, plan values, root module? Well, it's the same one in here, planned values, root module, child modules. So the JSON blob that comes out of the Terraform plan, we map directly as an input, right? And we just pick the keys and values out of it. So it helps to have them side by, I like having them side by side. It makes it a little bit easier to understand the schema. It's usually the same, but sometimes you have these like modules, addresses, modes, etc. So all of this information here will tell you what's going to be actually configured. So in this case, we'll go back to here. So I've already created a variable, which remember, we have rules that have return values. So this, I've already created a variable that looks for the Google resources specifically. So here it's retrieving the plan modules, child module resources. It's looking specifically for provider resources. So it's looking for the Google resources only. And that's why I call it GCP. So it's looking for GCP resources. So here I'm just making it easier for myself to just say, all right, I'm going to retrieve GCP resources, and this underscore means retrieve all GCP resources. So in terms of what I'm going to look like, what it's going to look like here is that I'm going to create a bunch of resources, and that's coming from a list of GCP resources. So the Rego language basically will allow you to read in the input and then pull that information and put it all together. So that's step one. The next bit of it is saying, okay, let's actually look at what these values are, right? So we have to look at whether or not the password is of length 16. As you can see here, Terraform in state puts them in plain text. This is a well-known, I know, this is a well-known thing. This is a well-known problem. The hope is that the state files in Terraform, hopefully by next iteration, or the iteration after that, will encrypt them or actually not have them at all. So there's some architecture. So if anybody's interested in contributing to some of the architecture decisions around that.
Is there a way where you could call out to your secret store and like programmatically have it take the secrets from your secret store rather than from there? Like, I know that in a lot of CI/CD pipelines, you can have it call out to your secret store and then programmatically access your secrets in the pipeline. So, you know, like you're going to do this and publish to there. And so then the secrets are stored nice and safe. And yeah. I think your company might make a secret store.
Yes, there is a vault. There's Vault. And so the reason why it hasn't been done before is that a lot of people wanted to manage a lot of resources. And it was very difficult for people if they wanted to manage keys, they wanted to manage accounts, they wanted to do this rotation of keys in Terraform. And it's really hard to make a diff of something that you don't really have full access to. And there are some complications to doing it. So the practice that most people will actually go through is not actually doing this. They'll actually encrypt state entirely. And they'll also, as a result, not actually expose this TF plan as openly as this, right? So right here, I'm using it as testing. Most people would actually take this blob and actually if they were using OPA in a purely open source way, they would take the blob and they'd store it in Vault, which is our secrets manager from Hashicorp, and then to use restrictions, right, on the state file or this plan file itself. So the whole blob itself is considered sensitive, which isn't, unfortunately, it's not really the best solution. So yeah, if anybody.
Sorry, if the whole thing is in the vault, then that means that you can't really do this analysis on it.
You can do the analysis, but you would have to make sure you have the correct revocations and leasing from Vault to ensure that, to ensure that you're not allowing this sensitive information to just live there all the time. And so access to this plan information, you would only be limiting to the policy engine that you would be retrieving from. Under the hood, that's actually how Terraform Sentinel works. There's a SaaS offering that we have for Terraform Cloud that actually does all this end to end. And what it's actually doing is retrieving that sensitive information, that whole state and that whole plan, and it's limiting the amount of time that someone has access to that sensitive state.
Why are there so many cool security tools named Sentinel?
I don't Oh, that one I have no clue. That's not an answer that I can give. That's
I think it's from the Matrix. I don't know.
Oh God.
Okay, I'll let you continue.
No, I actually wonder that now though. It's probably because people are watching for it. But yeah, it's one of those things that I think that this is something that it's continuing to improve. And traditionally we said just take the whole thing, store it in sensitive state, right? But the reality is you don't want to store a whole JSON blob like this as a sensitive, variable or sensitive blob. Yeah, it's not sensitive data. So we're working on the architecture. So if anybody has thoughts, I'd love to hear them, because it's been a puzzle. There have been a lot of debates back and forth how to best to do this. But the idea is here we're going to look at this, and say it's sensitive. We'll assume that we've made sure to have a time to live for the least to the sensitive data, and make sure when you do it in open source, and if you're using open source like this pattern, using your own CI framework, make sure you do that kind of research and understanding, and you actually put those put the time to live in place, because it does have sensitive information. But also, as a side note, Google does not actually endorse this username password for your Kubernetes cluster as a pattern anymore. Technically, you should be using OWASP. So yeah. So besides even the password length here, we can actually expedite this process, because I know we have 20 minutes and I want to make sure we get questions and patterns and stuff. But more importantly, actually, you can see here, I do have a rule that checks for username and password. So it's actually looking to see if username and password are defined. In Terraform, what I basically said was in the provider, so this is what Google provider, that's what the language is. But in the provider, I actually specified a username and a password, right? And as I said before, Google actually doesn't endorse, the Google Container Engine doesn't endorse this as a pattern anymore. So as a security, as a security team or someone who's more aware of this, I might say, hey, make sure none of the usernames are defined. Make sure none of the passwords are defined. We shouldn't be using usernames and passwords anymore at all for a Kubernetes cluster. And it makes it too easy for someone to use basic auth, right? For example, to log in by username and log in by password. Maybe I just want to use tokens. So actually, as you can see, I evaluated this and it says cluster must not use basic authentication with password and username. So this rule in itself, right, this is just the way that it's checking. And you can use in sort of best practice, you would want to modularize these sets of policies. So here I'm actually running the policy that actually checks for this. So I'm actually saying deny check username and password greater than 0. So basically, if any username or any password for any Kubernetes cluster that I'm creating in Google is being username or password, do not do anything, right? That's not something you should be doing. You should be using tokens. You should be using service accounts. You should be using all the Google constructs that you would want to include that. Similarly, in the case of Kubernetes, and especially in Google, they allow you not to use a client certificate as well. So you should actually disable the client certificate as well. So all of this stuff is policy that you're actually able to check. So the reality is that, we didn't really maybe even need the funny thing about this story or this process is that as someone who might have blindly gone in and just sort of built this configuration, built this infrastructure, by being able to see some of these rules and work backwards, I'm able to say, hey, I'm learning a little bit more about better practices in security. It's all codified. It's all written for me. It's a fitness function that tells me how close I am to how conformant it is to my security architecture. So it's a neat way to actually use it. With OPA itself, there's a lot in the Rego language that we could probably go into that takes more than an hour. But the idea is that we've got a start here to understand what we need to do to enforce the security on this Kubernetes cluster.
Rosemary, do you sort of see this as like, if you are in a small startup, obviously, there's probably limited checks that go on here before code gets infrastructure or regular application code gets pushed to production. But if you're in the large enterprise, do you sort of see like as DevOps continues to evolve in like a large enterprise, you have developers who are learning infrastructure and you have infrastructure people that are learning development, right? Do you sort of see like the operations side is developing some of these policies, and that the infrastructure, like they're like, all right, SSLS be enabled on every, internet call. You have to have these types of lengths of passwords. You have to comply with our password policy and things like that. And do you see those policies getting dictated from one side and then pushed down to like the development side? Or I guess culturally, how do you make something like this work? And that's kind of what I'm asking.
So this is really fun. And I was, was something that I came from a background where I was someone who was working on a DevOps team building infrastructure. And I didn't really know like the really detailed practices. And for me, I was still learning what are the ways that people could, come into the system and compromise it. So I would actually sit with the security team and pair with them and actually like write out the code. I'd ask them, hey, can you tell me what this policy is or what this practice is? Do you want it to be a username, a specific password? Do you expect a time to live for the secret to be a certain threshold?
Mm-hmm.
What is the policy that you are looking for? And then I'd actually take that and describe the narrative in code.
Okay.
And eventually, it actually even happened with compliance to a certain degree, where you're able to say, hey, in order to comply with SOX compliance, you need 2 approvers, and both of them must be different. And those were checks that could be done through APIs with code.
Yeah.
And once those got developed, those policy sets got developed, we were actually able to say, let's take those policy sets and apply them into each pipeline, so that before you go to production, you have to have these rules passing in order to be fully in compliance.
Right.
And there are multiple ways.
Do you sort of, I guess just from an OPA standpoint, like let's just say you did something really not cool, like you're deploying to a region that you shouldn't deploy to, and that breaks the build and breaks the pipeline, basically says you have to go change that before you could push. Are there like warning checks that you could trigger instead of breaking a build check? Like are there thresholds of non-compliance, like low non-compliance, medium risk, high risk?
Yeah, so in here, let's actually OPA eval. So part of the really interesting thing is that you can kind of define, right, to a certain degree, to what extent you want it to fail or not fail.
Okay.
Yeah, so it depends on how you specify the language itself, right? So you can say these things are a hard fail, while these things are, a soft fail. And you have to sort of build that into the language, the rules and the policies themselves. The nice part is that you can divide them into these different packages, and you can say this group of packages we might consider a soft fail, and then this group we consider, must not go to production at all. So you can actually adjust it based on these paths, right? So you can say data GCP Kubernetes, check tags, this may be a soft fail, versus this username password here, this policy here, may be something that you cannot go to production with. It will also differ, but depending on environment. So if you put it in a pipeline, you'll be able to control which packages run with which kind of degree of failure.
Right. Cool.
Yeah. It's interesting.
Yeah. And since you're such a Kubernetes expert, all right, I know nobody in the world I think is a Kubernetes expert, but anyway, can you in OPA like check inter Kubernetes things?
You would have to write it. Yeah, and that's tricky, right? Because so OPA has 2 modes of running, and I think this is a really interesting. It's a good pattern to have, right? So there's shift left testing, which a lot of people focus on for the context of getting feedback really quickly, making sure you address defects very early on and you're in the development stage versus waiting until production. And then there's the live monitoring, right, of what's going on. And OPA will actually do both, at least in the Kubernetes space. So OPA as a policy engine can be extended to do shift left security or policy checks, but it can also run in the Kubernetes cluster as something called like a controller. So it will just loop and consistently check for metadata, just like it's checking for metadata here. But there's a control loop that tells it to keep checking. And in order for you to run OPA in the Kubernetes cluster, you also have to tell it the specific rules you're looking for between Kubernetes clusters.
And what is it checking? Where is it running when it's checking? On the Kubernetes host itself?
Yes, so it's running on the Kubernetes host. It's under this thing here, actually. So what it's effectively doing is that OPA itself runs as its own container or as its own service. And so it's actually checking, you can choose where or how far it's supposed to be checking, but you could check the entire cluster. It could check localized to a certain namespace. It sort of depends.
Yeah.
Yeah.
Cool.
Mm-hmm.
We currently have no questions in the chat, just so that you know. I added links to OPA, Terraform, Circle CI, and the policy language in the chat, just in case anyone wanted to follow up on it. But it appears that you are explaining everything perfectly, or everyone is just in such awe that they're just like,
is there like a rules YAML file? Like where are the rules stored here? How do you manage the rules?
So I manage the rules, at least with these imports here.
Okay.
There are also bundles that you can do. So you can have, let's say you want an upstream bundle that someone's pre-created. You can say use that bundle. So someone's already done that. This is just easier for me to define overall, just with this hierarchy, because in my coding preferential experience, I don't recall if there is a full YAML, although someone probably
will. Yeah. And do people like open source like other rules? Like, are people like, oh, I wrote this really cool rule for checking, I don't know, something.
And that's what's really interesting about the policy as code space right now. There's not too many of them.
Okay.
There are some bundles that people are trying to work together to build. So there are some of them, but not comprehensive. So what's really tricky about this space, and what I personally was having difficulty with, was, for example, if I needed to ensure GDPR compliance, I wanted to put it in my pipeline, I would have to sit and pair with a compliance officer who knew GDPR really well to actually write all of that.
Mm-hmm.
There are maybe some open source libraries out there that have them created, but not all of them are open source, and none of them are openly available. So
right, so you're kind of on your own to construct the boundaries here, and I guess some are more simple than others. Like, is the S3 bucket public or private versus is this GDPR compliant is like a universe of yeah.
Is there a place where people are sharing stuff like this online, like a specific place where people are putting a whole bunch of things together for people to try out?
There is the OPA Playground, so you can do individual checks, right, of OPA rules, so you can play with the language. Let me pull that up, actually. There's this Rego Playground. So you can have individual rules and you can test them out and play with them. GitHub is the best place to look for larger groupings of rules. Some of them will have suites, some of them will not, some of them will just have some simple rules. Even the examples right now in OPA may or may not be fully, full comprehensive coverage of, let's say S3 or IAM rules in AWS. And there is actually another tool called ConfTest, which actually wraps around OPA. And shout out to the contributors of ConfTest here. It's actually pretty neat. Basically, they actually have a couple more examples of how you would run this from a shift left standpoint. They don't really, you can tell it to do sort of the monitoring and the live control loop, but here it's mostly focused on doing it sort of at the beginning of the pipeline. And it's a tool that wraps around it just to make it a little bit easier. So as you can see, you can say, hey, does it have this? Does it have that? And they have some pretty good examples with a strong community kind of always building some additional examples as well.
How would I start doing some of this and not get fired?
That's a good question. So think of some things that you wish you knew before. And you sort of would, if you were to communicate this with your past self or someone in the future on your team, write some code for it, write some Rego for it to do the check. I think that's how I started, and it worked out really well because this is not something that it's not it's critical, but it's not to a point where you would say it breaks pipelines. You can set it in a way that it's not going to break your pipeline and prevent pushing to production, but it's a way to build a shared understanding with your team. And then once you get more familiar with the language and you get more complex rules, then you can say, okay, if it fails, delete it or stop the pipeline entirely, don't push to production. But some of the things like I wish I knew, for example, whereas like don't run a container as root, in Kubernetes. So that's a rule that you see here. Don't put TCP 0000 any production instance unless it's like a very specific component or very specific type, and you expect to see that.
And you have it in writing from someone who has permission and will take the blame and have their name in the newspaper when all the crap happens.
Exactly. So if you have that, right, that says, hey, we made this decision. And I think that's what's really powerful about this and saying policy as code. You can say, here's the commit, and not to say blame, but just to say, okay, someone made this commit to open up the firewall rule, for example. And we can say, okay, here's the issue, or here's the change record, right, that said here's where we got the approvals to do it. So you have that information, you have that inversion control, you see where the changes were, and if it doesn't work or it's not a good idea, you can always revert it and back out. So you can always go back to the original state.
Cool. And I know you used Terraform as an example here, but this works on CloudFormation too, correct?
I believe they have some CloudFormation. It will work on anything with JSON, actually. So they don't have any examples of CloudFormation, but if you export the CloudFormation as a JSON and you actually understand the JSON hierarchy pretty well, then you're actually able to run it against any JSON blob.
Does it work on YAML?
No.
Okay. I was just like, never know. If I don't ask, I won't know.
Yeah, it's true. It's true. I don't believe it actually works on YAML unless you convert it to JSON first. I did try it on YAML and it didn't end well, but I think I might have been missing something. So
cool. Very, very cool, Rosemary. This has been super fun.
Yeah.
Everyone on the chat is just like, she's awesome. This is great. All her explanations are good. The questions are good. This is fun. Thanks for the live chat. Yay, and smiles.
I'm glad. And it's, like I said, it was a learning process for me, right? And so this wasn't something it wasn't something that I just immediately knew. And I depend on subject matter experts to help me figure out the best policies to write for a given circumstance or a situation. And it's been such a great learning experience to be able to ask people, okay, does this policy apply here or does it not apply to here? And how do I get a better holistic view of it?
Whoa.
I feel like this was a really nice introduction to this topic, and that we're going to have all of the people in the live chat running off and writing some new JSON and then destroying it. There's a lot of people in the chat saying thank you very much.
Oh, thank you all for joining on a weekend and learning something with me. And if you're interested in learning more, feel free to tweet at me. It's complicated, but it's JOATMON08. It is the first letter of Jack of all trades, master of none 08. And if you're interested in learning more, contributing, definitely feel free to reach out. There are a lot of tools out there that can really help with this.
I'm just going to tweet your handle so then people won't mess it up like I did earlier. Cool. Nancy, when will this video be available for people to watch that missed it?
Right away, actually. We'll probably edit the first part where they couldn't hear us. But right now it's live on YouTube, but as soon as we end, it will be there. And I'll take all the links that we've mentioned about OPA, about the book that you've mentioned, and put that in the notes and your contact information if they want to reach out. But yes, I wanted to add that the Slack community for CNCF OPA is very active. So when you have questions about that, if you want to get started, that's a good place to ask your questions. They've been very friendly answering questions for beginners. So that's always a good place. Yeah, I have nothing to add. Maybe we could do a round table. Tanya, anything to add before we wrap up?
So that was super fun. And now obviously I want to go mess around with it. So I appreciate that. I've never played with Terraform yet. So now I have quite a lot of excuses to do so. So that's really cool. Thank you very much for being on our show.
Thank you for having me today.
Nicole,
yes.
Yeah, no, this was great. Yeah, I really enjoyed the way you walked us through this. I think we all have a lot of time on our hands now, hopefully, right?
Yeah.
So we have no excuse now to learn new things.
Yes.
There's one more question in the chat. So Nancy, could you share the Slack channel link in the live chat?
Absolutely. Well, maybe not in the Slack. I'll take some time to find it, but okay. I'll put it in the show notes for sure.
Okay. And Rosemary, what's the difference between OPA and Terrascan? I've never heard of Terrascan.
Oh, there are many, many tools out there, and all of them kind of under the hood run just a little bit differently. It sort of just depends. I don't know if Terrascan is actually based on top of OPA or not. It will allow you to do similar scans of that plan as well. And so if you want to go with a Terraform specific tool, Terrascan's out there, Sentinel is out there. OPA is more generally open source, very broader spectrum. The engine itself is for giant JSON. So
cool. Thank you.
Thank you.
And Nancy?
Okay, so I think that's it. Thank you, everyone. Thank you. That was fun. And we don't have any more show planned for the rest of the month, but we'll see you next month. And follow us everywhere on LinkedIn, YouTube, Twitter.
Dev.to.
Pardon me?
Dev.to.
Yes, dev.to, to see what's next. And don't miss any more shows. So that's it. Thank you. Bye.
Bye.
Thank you, guys. Bye-bye.